Okay, so section 7.2 is on graphing polynomial functions. So we've already kind of graphed polynomial functions. This is just going to do a little bit more information. So it says when we graphed polynomial functions before, we made sure to find the zeros or the x-intercepts with factoring. But sometimes zeros aren't very easy to find. So let's say it was like you had a zero that was like a square root answer or something, or a fraction. So maybe it's not very easy to find. So it says also when we graphed before, we didn't know how to find like the high or the low parts of the graph we wanted. So if we had a curve that went like this, we didn't know how to find that point there. We just had a rough sketch. So we will also learn how to find the maxima and minima. Okay. You can find it by hand with calculus, but we're going to talk about some other methods in Algebra 2. All right, so number one, it says graph f of x equals negative x cubed minus 4x squared plus 5 by using a table of values. We're going to use end behavior to help us. Okay, so the table of values, like that. And I'm going to plug in different numbers. So easy numbers to pick, obviously 0, 1, negative 1. You could also try some bigger numbers. And then let's talk about the end behavior too. So do you guys remember end behavior from yesterday? So what is this going to look like on the ends? Are they both going to go up like x squared, both down like negative x squared, one up, one down like x cubed, and then the opposite like negative x cubed? So is it going to look like 1, 2, 3, or 4? 4, right? Because the leading number, or the largest degree is 3, so it's odd, and the leading coefficient is negative. All right, so it's going to look like the fourth one. Oops. It's going to go down like that. So if you want to do that on your graph, you can. All right, so let's go ahead and plug in our numbers. So if I plug in 0, that one's easy, you get 5. If you plug in 1, you get negative 1 minus 4 plus 5. So you get 0. So that's one of our zeros. So 0, 5, 1, 2, 3, 4, 5, 1, 0. If you plug in negative 1, you get negative 1 cubed minus 4 times negative 1 squared plus 5. I always like to write it out with the negative 1 in parentheses. Kind of helps. Then you can see that when you have negative 1 cubed, what do you get? You get negative 1, and then you have a negative out front, so negative 1 times negative is going to be 1. So you have 1. Okay, then you have to do the power first on this one too. So negative 1 squared is 1. Then you have negative 4 times 1, so negative 4 plus 5. So you get 2 on this one, so negative 1, 2. Okay, let's try a couple more. So how about we try 2 and negative 2? So how about from Carolyn over on Sarah's side, well, Sarah with the no H this side. You guys are going to do the 2, and then this side you guys try the negative 2. See what you get. Okay, what'd you get when you plugged in 2? Anybody do 2? This side of the room, no one did?
I got negative 19.
Negative 19 is correct. Okay, what'd you get when you plugged in negative 2? Negative 3, right. Okay, so let's see what that's going to look like. So you have 2, negative 19, so it goes way down real far. So that makes me think that this arrow, is correct. It's down there. And it's just going to keep going down further. All right, and then I have negative 2, negative 3. Okay, and this has added kind of an interesting thing to our graph because we know we have to go down and touch that negative 3, and then we're going to have the rest of it, right? But we don't really know how far down it goes. So before I do that, I want to try a couple more. I want to try maybe like negative 3 and negative 4. Okay, and if you try negative 3 and negative 4, you're going to get negative 4 and 5. So negative 3, negative 4, 1, 2, 3, 4, and then negative 4 and 5. Okay, now that gives you a pretty good estimate of where your graph is. Okay, there's a pretty good sketch. Okay, we did all that without factoring. This one we wouldn't have been able to factor. And we have a pretty good idea where another 0 is, right? So right here, we know that there has to be a 0 between, let's see, 1, 2, 3, 4. This was negative 4, and this one was negative 3. So there has to be, so there's a 0 between x equals negative 3 and x equals negative 4. Does that make sense why there has to be a 0 there? Okay, because those are consecutive numbers and it has to cross the axis because one was above and one was below. It looks like there also has to be another 0 right here. So there's another 0 between, and you can see the points that we have here. This is at x equals negative 2, and this is at x equals negative 1. So there's another 0 between x equals negative 1 and x equals negative 2. Kind of a little hint. If you had degree 3, the most zeros that you can have is 3. Okay, do we have all 3? Yeah, we have one somewhere in there, somewhere in the red circle, and one over here at x equals 1. So you could say the last 0 is at x equals 1. Yeah. Okay? All right, so relative maximum or local max. So a relative maximum is a point on the graph where nearby it, there's no points that are higher than it. So if you look, if you look back at what we did, there is a relative max right here. So what I just circled. Now that's not the highest point on the graph. There's points over here that are much higher than it. But in that general location, if I zoomed in that one particular area, there is a highest point. Does that make sense? Okay, that's what we call a relative max or a local max. Same thing with relative min or local min. That's not the lowest point on the graph. But in that general area, it's the lowest one. Make sense? Okay. So it's basically like all of the different hills and valleys on your graph. Okay, so example. It says determine the consecutive values of x between which each real 0 of the function, so this is kind of what I did in the last one, is located. Then draw the graph. Okay, so let's set up our t-table again. And we're going to try different values. So I'm going to have 0. When I plug it in, I get 1. When I plug 1 in, I get 1 to the 4th, so 1 minus 4 plus 1. So I get negative 3. When I put in negative 1 to the 4th is 1, minus negative 1 to the 3rd is negative 1, minus 4 times negative 1 squared is 1, plus 1. So you get negative 1. Okay, and then we're going to try 2 and negative 2. So if you had 2 before, do negative 2 this time. If you had -2 before, try 2 this time. Give you a second to try it. Okay, what'd you get for 2? -7, that's right. Okay, what'd you get for -2? 9. Did you do both of them in that time? You're speedy. Was that you that said it? Okay. All right, so I get 0, 1, 1, -3, -1, -1, 2, -7, -2, 9. So -2 is way up here somewhere. Okay, think about the end behavior. It's x to the 4th. And it's positive. So your end behavior on the end should go like that, right? So this one looks pretty straightforward. You're going to come down. You're going to have to go back up to that point. Go down. But then all of a sudden I know I have to come back up. So that end behavior is helping me because I know that I'm missing some information on this side of the graph. So that means that we should try numbers like 3 and 4 on our t-table. Oops, it's locking up. So try 3 and 4 on your t-table. Doesn't like me. It's frozen. Okay, when you plugged 3 in, what'd you guys get? 19. And when you plugged in 4, what'd you get? Really big. 129. Good. All right, so that means 3 is way up here already. So that's how we know that it goes back up. Okay, I just made it look like it goes through at 3, but it doesn't go through at 3. So be careful with your sketch. It goes through right before 3. Okay, so think about where your different zeros are. We have 4 of them. Did you guys see the 4 different zeros? Right here, 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 and here. So 4 x-intercepts. Okay, so we have zeros between. So I'll write it like this. So zeros between. So the first one, it looks like you were between -2 and -1. So x equals -2 and x equals -1. The second one looks like it's between x equals -1 and x equals 0. The third one looks like it's between x equals 0 and x equals 1. And the last one is right before x equals 3. So it's between x equals 2 and x equals 3. Okay, yes?
But the way that you draw it makes it look like it's on the 3. Is it wrong if you said like...
Yep, so when I first drew mine, it looked like it was going through 3, but I knew that it couldn't go through 3 because I had this point up here, 3, 19. So that's the y value that goes with 3. Remember, this is a function, so it should pass what's called the vertical line test. And you should never have a point going through x equals 3 in 2 places. Makes sense? So that's how I knew it had to be before 3.
I have a question. Why is it necessary to have the zeros? Like,
The zeros are going to be really helpful when you're solving like real life problems. So I don't know, I can think of all kinds of calculus examples. So if you're like trying to maximize or minimize your profit and cost, we do something we call like the derivative, and then we find where it's equal to 0. So we find where the x-intercepts are. So zeros will be very important. They also help you factor really crazy polynomials. So we'll do that in this chapter. Okay. Oh, is that it? Okay, I also wanted to show you guys kind of a shortcut because I know doing t-tables is tedious and you guys aren't really big fans of t-tables. And sometimes it's very easy to mess up on a sign. So I wanted to show you a trick with your graphing calculator to help you with t-tables. So do you guys have your graphing calculators today?
No.
No. All right, so get next to someone that has one, kind of share. Okay, so all you're going to do is you're going to go to y equals. So do you guys know where y equals is? So y equals, it's up in the top left corner. And you're going to put this function in. So you're going to do x. Do you guys see where x is? It's underneath mode. It says xt theta n. That's your x. So it's a button that looks like this. It says xt theta n. So you're going to caret raised to the fourth. So this is your caret. So raised to the fourth minus 3 x raised to the third minus 4x raised to the second plus 1. Okay, you can check that you're graphing your polynomials correctly by hitting graph. So when you hit it, you should have a general shape of what it should look like. Do you guys see how you can kind of see it when you hit graph? So that's not what I'm concerned with. I'm concerned with the t-tables, because if I'm going to ask you to do a t-table, I want you guys to have accurate numbers in your t-table. So a way that you can check your numbers is you're going to do second table. Table's right above graph. So second is in the upper left. Graph is on the right. And you have a t-table that's created, right? It says x, y, 1. Now, your numbers are already there probably, right? Are there already numbers there? But if you want to make it so that you can use whatever numbers you want, you can adjust this table. So here's what we're going to do. This is a tricky one, so pay attention. You're going to do second table set. That's above window on the top row. So second table set. And you have this screen, and it says like table start, table, independent, dependent. Do you guys see all that? I want you on the independent line, arrow over to ask, and hit enter. Okay, now go back to your table. So do second table. Now your table should have, it should be blank. Some of yours won't be, but some of the newer calculators still have numbers. But now you can adjust whatever numbers you want. So under x, so under the x column, you can put in whatever numbers you want. So put in like -1, 1, 2, 2, 0, 3. So you now know how to create t-tables on your calculator. Okay, now this is a useful trick to have. It's nice to have calculators. We like them. But here's the thing, a lot of times you're not allowed to use your calculator. So on the AP test, like 2/3 of the exam is non-calculator. So you need to know how to do things without using your calculator. You need to know how to do t-tables by hand. That's why you've learned them so many times by hand. But this will help you on your homework to quickly come up with some values, okay? Make sense? Yeah, Andrew?
So what do you do once you get to the ask?
Oh, hit enter on the ask, and then do second table. So go back to your table, and then you can put in whatever values you want.